exploratory data analysis. Exploring and understanding your data before conducting analyses is very important because it helps one detect missing data. So what is missing data? Missing data is when there is no data value for a variable. Missing data can occur if participants forget or refuse to answer a question on a survey, if data isn't recorded properly, or if it's just lost. Unfortunately, having missing data is a common occurrence and can have a significant impact on conclusions that can be drawn from the data. Missing data can lead to misleading results by introducing bias. It also poses threats to validity. It's important to have some prevention strategies to try and combat the issue of missing data before you even begin your study or experiment. Training should be given to everybody involved in the study prior to the start. This training should include how to collect and enter data and how to implement the treatment or intervention if necessary. A verification technique during data input could also be used to aid in combating recording error, such as having to put the data in twice to see if any of the numbers don't match because of typos. The design of the study should also try and limit the amount of follow-up visits. It may be hard to keep subjects in a longitudinal study. So to help combat subject dropout, it's important to recruit motivated participants to participate in the study by providing rewards or incentives. And even after doing all of this work, you may not be able to completely prevent missing data. Therefore, you must be able to identify it and know how to handle it. Data can be missing completely at random. This is when missing values are independent of observed and unobserved considerations of interest. The missing data are unrelated to the study variables and happens entirely at random. Missing at random occurs when the missingness is related to a particular variable, but not to the variable that has missing data. For example, if someone just forgets to answer or accidentally skips over a question on a survey or questionnaire. Missing not at random is when the value of the variable that's missing is related to the reason that it's missing. So a question on a questionnaire that may be skipped on purpose by certain types of people. You also need to determine the best analysis strategy that provides the least amount of bias with missing data estimates. And there are a few procedures for handling missing data. There's list-wise deletion, which involves removing the entire case or subject that has missing data and analyzing what is left. This could be problematic because if your sample size is already small, this reduces statistical power. It also is problematic when data is missing not at random because you could be missing an important aspect of maybe which kinds of participants skipped which questions. There's pairwise deletion, which involved only removing specific missing values, not the entire case, but only when the specific data point needed to test a particular assumption is missing. Mean substitution is where the mean of a variable is used in place of the missing data values in that variable. Although this approach increases the sample size, it leads to an underestimate of the errors and reduces variability. In regression imputation, the existing variables are used to make a prediction about the missing values. The predicted values are put in for the missing values as if it was an actual value. Just like in mean substitution, regression imputation adds no information to the dataset. It increases sample size and avoids significantly altering the distribution. The last observation carried forward method replaces every missing value with the last observed value for that subject. An issue with this method is that it's not likely that the value of the outcome is unchanged. So it's important to report in your study which method, if any, you chose so that your findings can be interpreted and replicated appropriately. So now that I've talked about missing data, I'm going to talk about how to discover missing data. Exploratory data analysis is a process used before inferential statistics as a way of carefully examining your data. It helps you get to know your data and control for any mistakes that may have been made. Researchers should explore their data before conducting hypothesis testing to avoid things such as distributional problems, scaling anomalies, and outlier observations. EDA is a first way to access what kind of influence the missing data may have on your results. So here is a missing data set, or here is a data set that explores smokers and non-smokers of various ages who do not exercise regularly. Their heart rates, and it measures their heart rates before and after aerobic activity. Participants were asked to record their age, sex, and whether or not they smoke. Their pulse was taken, and then they ran on a treadmill for 5 minutes, and their pulse was recorded again. This study wants to explore whether those who smoke have a higher pulse than those who do not. So if we just scroll through the data here, we can see that there are a couple missing data points here and here. One person didn't indicate their sex, while a few others did not indicate whether they smoked or not, and a post-exercise pulse is missing. This is perhaps due to data entry error. But I'm assuming that these data are missing at random. And I decided to explore whether the participant smoked and their pulse after the exercise. So here, the case processing summary shows how many cases provided data for the analysis and how many were missing. So I can see one smoking group was missing because that is the group where the post-pulse is missing. The descriptives table right here tells us important information about our data distribution. We can compare the post-exercise pulse rate between smokers and non-smokers. According to Ehrenberg, the strong criterion for a good table is that the patterns and exceptions should be obvious at a glance. Here, we can see that it's not easy to compare the numbers at a glance because the columns are stacked rather than side by side. So in a normal distribution, the mean and the median would be equal. Here, for the no smoking group, there's a difference in the mean and the median of about 3. That's not too bad considering when we're talking about people's pulse. And there's a greater difference in the smoking group. It's a little over 6. So neither of these groups are normally distributed. In the article we read by Rasmussen, which discussed approaches to dealing with non-normal data, data transformation is superior when compared to parametric and non-parametric approaches. So as we can see, the mean pulse for those who smoked is over 15 beats higher than those who do not smoke. I also like to look at the range of the values, the minimum and the maximum. Just in case there was a major data entry error, I can try and catch that here. For example, if 12 was entered instead of 120, I would assume that there was an error because if someone had that low of a pulse, they would need to be in a hospital and not in the study. So I'm also going to look at skewness and kurtosis. If we had a perfect normal distribution, these values would be 0. For the no smoking group, we have a bit of a negative skewness, so the tail will go to the negative side of the axis. Their kurtosis is also negative, so the distribution is going to be a little on the flatter side. For the smoking group, the opposite is true. The distribution is positively skewed and the kurtosis is positive, so we can assume that the distribution is going to be pointier. Next, we'll look at the test of normality table. It shows 2 tests of normality, but we're going to look at the Shapiro-Wilk test because it's better with smaller data sets like with what we have. So here we see that the non-smoking group is significant and the non-smoking group is non-significant and the smoking group is very significant, sorry. This implies that our data for the smoking group is not normally distributed. This is confirmed when we look at the histogram. The no smoking group looks close to normally distributed, but we can see the tails going towards the lower values. In the smoking group, we can see that this outlier right here is causing the positive skewness in this distribution. This is also confirmed with our normal QQ plot. If we had a normal distribution, we'd expect all of the data points to line up on this line. These dots not on the line are where we can see our skewness, the deviation from the normal distribution. As we can see, the no smoking group is closer to being normally distributed than the smoking group is. But we must be careful when looking at graphs like this, because according to Weiner, data can be misleading if the scale does not start at 0 or if the scales are different. In neither of these graphs, the scales start at 0. They both start at 100. And the observed values in the no smoking group increases by 20, while in the smoking group, they increase by 50. If we had a normal distribution and the detrended normal QQ plots, all of the points would be around and near this deviation from normal line. As we can see, they're not. So next we're going to look at our box and whisker plots. This splits our data into 4 quartiles. It shows us the medians and the different ranges. We can also see this extreme outlier in the smoking group. So from here, we could explore some moderating variables such as age or gender to see if they strengthen or weaken the relationship between smoking and pulse. So today I talked about missing data and exploratory data analysis. Getting to know and understand your data is extremely important in the research process.